Good afternoon, everyone. My name is Christy Sapp, and I'm the Global Market Development Director for Green Mantra Technologies. Before I dive into my presentation, I'd like to echo Kim in thanking the prop team for giving us this opportunity to share our story about developing a new end market for waste films. And I'd also like to thank each of you for taking some time to listen to our story today. Green Mantra's mission is to make a significant impact on the diversion of waste plastics from our environment. We're achieving this mission by practicing a unique business model where we intercept underutilized materials that have a low value and are destined for landfill, and then transform them into specialty waxes and polymers that have a tangible value for our customer. That tangible value is often translated into improved profitability for our customers. For example, by providing higher throughput in an extrusion process for a plastic drainage pipe, or by enabling asphalt road companies to create more durable roads with less materials. Ultimately, Green Mantra materials allow manufacturers to achieve increased sustainability without sacrificing performance or profitability. By creating a more versatile specialty wax from waste plastics, we're creating a product that can now be used in a wider range of industrial applications. This allows Green Mantra to achieve our mission to significantly reduce the amount of plastic that ends up in our environment and oceans. Green Mantra has rapidly scaled our technology over the past decade. The company was founded in 2011, and by 2016, we'd fully scaled our manufacturing operations and developed significant commercial business with our products. Last year, due to increasing market demand, we doubled our capacity at our manufacturing plant in Ontario, and this has allowed us to begin moving into new geographies and add additional new products to our portfolio. Each of the images on this slide was taken from our commercial manufacturing facility in Ontario. Let's do a quick look at the landscape of advanced recycling and where Green Mantra fits in. Advanced recycling is critical to achieve a more circular economy, as it can accept challenging plastic streams that are unsuitable or uneconomical for mechanical recycling. We can visualize the concept of advanced recycling with Legos. On one end of the spectrum is pyrolysis. In this case, plastic is broken down into its building blocks. On the other end of the spectrum, you have purification. In this case, you use solvents and other tools to remove color and additives from the waste plastic, refreshing it to a virgin-like quality. Green Mantra resides in the middle. We use a catalyst, which is represented here by the little Lego man with scissors, to make a few selective cuts. This creates a whole new range of unique, high-value additives that are ready to be used by our customers to enhance a wide range of applications. To reduce or eliminate plastic waste, we need to create as many pathways as possible for recycling. Green Mantra often describes our approach to plastic waste as thinking outside the circle. Our business model is grounded in the fact that we upcycle undervalued plastic streams, such as polyethylene films, into value-creating polymer additives that can be used inside and outside the plastic industry. By upcycling these undervalued plastic streams and creating valuable polymer additives, we open up more markets to generate demand for waste plastics. These new markets include things like asphalt roofing and roads, where recycled plastics were not previously used, which also have a significantly longer service life than that original plastic bag. This allows us to recapture the value of these waste plastic streams, using them as a resource. Our positive environmental impact is enabled by each step of our business model, from raw material all the way through to our targeted applications. Our feedstocks are waste plastics, and we target streams that others can't use. Our process is unique in that it's extremely efficient. The catalyst does all the work, allowing low energy demands, and no waste streams are generated. The only water that is used is recirculated to cool our products, meaning no wastewater treatment is required. Our process eliminates the inherent variability of recycled plastic streams, allowing us to create high-value specialty polymers with narrowly specified physical properties. Our targeted end markets are long lifespan products that sequester the original carbon for 50 or more years. In all our markets, we know that customers desire sustainability, but often decisions are driven by performance. In the specific market that we're talking about today, asphalt, engineers often like to characterize performance according to what they call the 3 E's: engineering, environment, and economics. Green Mantra delivers benefits in all 3 of those categories, and I'll tell you more about that in the upcoming slides. A few words about our feedstocks. This graphic represents the existing North American recycling infrastructure, with municipalities on the left and commercial facilities on the right. Mechanical recycling is the right option for recycling many plastic products, especially rigid and larger plastic forms, and it's critical that we continue to develop our mechanical recycling infrastructure as the primary route for recycling those plastics. However, as Kim mentioned in her presentation, there are many plastic forms that aren't very suitable for mechanical recycling, with one of the most notable examples being films. Some of these plastic forms are already collected in this existing infrastructure. For example, when a consumer places a film in a blue bin and it arrives at a MRF, it's separated out prior to the recycling process, baled together with other contaminated films. But it's not economical to clean and refresh those films, so without an outlet, they're often sent to landfill. Similarly, when a manufacturer or a retailer generates wet or contaminated films, the existing recycling infrastructure has few end markets that can incentivize the processing and recycling of those films. Green Mantra's objective is not to create new collection infrastructure. Instead, we're working with cities, states, and private partners to integrate directly with this existing infrastructure to capture films and other more challenging waste plastic streams and bring them to our facility. Our technology is complementary to mechanical recycling, taking those streams that the existing infrastructure cannot accept and offering an outlet to decrease the amount that goes to landfill. So here's a real-world example of how we can create value from a plastic feedstock that would otherwise be landfilled. In this example, we show how we can work directly with MRFs or commercial partners to intercept landfill-bound polyethylene streams. For example, polyethylene packaging films that often contain moisture, colorants, food waste, and other contaminants. We transform those streams into a specialty polyethylene wax to enhance bitumen. In case you're not familiar with the word bitumen, that's the highly viscous black liquid that's combined with aggregate to create the asphalt used to pave parking lots and roads. When Green Mantra's wax is added to bitumen, it helps create a better performing and more durable road. Another interesting benefit is that Green Mantra's materials enable a more robust asphalt formulation, which allows asphalt producers to incorporate other waste materials, things like reclaimed asphalt or ground tire rubber from used tires. So our products allow for better performance and also help the asphalt manufacturer to achieve a very high sustainability profile. As Kim mentioned in her presentation, there's been a lot of focus over the past decade to develop new end markets for recycled films, and asphalt is one of the most promising emerging end markets. This new type of asphalt has been deemed recycled plastic modified asphalt, or simply RPM asphalt for short. Asphalt often requires a modifier to increase its durability and performance at higher temperatures. Historically, those modifiers have been based on virgin polymers. RPM asphalt uses modifiers based on recycled plastic products instead of virgin polymers to enhance performance. The U.S. spends around $177 billion each year on highway funding, making it the largest category in public infrastructure spending, with asphalt roads comprising a large portion of that. Preliminary data suggest RPM can increase asphalt life and performance while creating an important end market for recycled plastic. Based on this preliminary data, some countries, especially in Southeast Asia, have rushed to incorporate high levels of recycled plastic in asphalt. This rush to find a new home for waste plastic without the proper science and technical validation work up front has caused premature failures in pavement performance in some of those roads. The highway program here in the U.S. takes a much more measured approach to using new materials in our roads, and studies on the engineering, economic, and environmental benefits are mandatory before any new asphalt technology is implemented into practice. A thorough review of the engineering and environmental suitability of plastics in asphalt is needed before undertaking full-scale deployment. I included here on this slide some links to resources from NAPA and the Plastics Industry Association that give additional insight into how the plastics and asphalt industries are working together to advocate for this research-based approach. Developing and validating a new end market for waste plastics and asphalt will require significant amounts of research, and we've seen lots of movement at the federal and state levels to support this research. These next two slides give a few examples of federal and state level legislation and initiatives designed to explore how recycled plastics can be responsibly incorporated into our nation's roads. This topic really came into focus earlier this year when Representative Tim Burchett pressed Secretary of Transportation Pete Buttigieg on why the UK was using waste plastics in asphalt, but the US is still lagging behind. This created a national spotlight on the topic, which prompted NAPA, the ACC, and the Plastics Industry Association to form a coalition to advocate for a technical and responsible approach to exploring the potential use of RPM asphalt. This second slide lists a few of the many initiatives at a state level. Most notably, there's an exciting project which is happening right here in Pennsylvania at Penn State, funded by the Federal Highway Administration. Pennsylvania is on the forefront of exploring the use of waste plastics in roads and has been taking a leadership position on this topic, with a lot of work underway already from PennDOT and local universities to explore how recycled plastic modified asphalt performs. The next few slides give an overview of the different options and benefits for creating recycled plastic modified asphalt, or RPM. First, it's important to note that standard asphalt itself, in an oversimplified state, is simply the mixture of liquid bitumen and aggregate in the presence of heat. RPM asphalt simply adds an additional component, recycled plastic, to the mixture. Depending on the method of addition of the recycled plastic, it can either become part of the bitumen to help bind the aggregate, this is called the wet process, or it can remain solid, replacing some of the aggregate, this is called the dry process. Each of these techniques has its advantages and disadvantages and yields different results. The dry process is a technique used widely in India and Southeast Asia, where recycled plastic particles are added at the end of the process together with other aggregates. The advantages of this approach are mainly due to its ease of use. It can be done at virtually any asphalt plant. The disadvantages, however, can be quite significant due to the inconsistent quality that can lead to premature cracking. Additionally, because the plastic particles are not melted or incorporated into the bitumen, they remain suspended in the asphalt, creating an increased risk for microplastic generation at the surface of the asphalt. The wet process is the technique that Kim introduced earlier as she described the work that was performed by the Plastics Industry Association. In the wet process, recycled plastic particles are added at the beginning of the process to the liquid bitumen. The plastic is fully melted into the bitumen prior to any addition of aggregate. This is a technique that is becoming more preferred for performance-based asphalt, as some preliminary studies have indicated potential performance benefits. The advantages of this process include improved asphalt performance, including better rut resistance. The disadvantages mainly lie in the fact that recycled plastics are not stable in the bitumen mixture, so they require high shear mixing and constant agitation to remain suspension in the bitumen. Some companies have developed compatibilizers that enhance the stability of the recycled plastic modified bitumen, but this adds significant cost to the final asphalt formulation. So although unmodified recycled plastic can be added to the bitumen via the wet process, the resultant modified bitumen is susceptible to phase separation and cracking issues. One effective approach to overcome these stability challenges is to chemically modify recycled plastics to improve their compatibility with the liquid asphalt binder. Green Mantra has developed a revolutionary new RPM technology by chemically modifying recycled plastics to create specialty waxes that are designed for asphalt. These waxes increase the thermal stability of asphalt, enhancing its stiffness and rut resistance. They also allow for lower paving temperatures, which can help reduce the amount of fumes and the overall carbon footprint of a paving operation. The difference between Green Mantra's recycled plastic waxes and unmodified recycled plastic can be visualized using fluorescence microscopy, or FM. FM is a scientific method that uses a UV light to analyze the miscibility of components and is often used to check the distribution of polymers in bitumen. Undispersed agglomerated plastic particles appears light green in the dark bitumen. This slide shows some FM studies performed by the National Center for Asphalt Technology. The first image shows FM analysis of 3% unmodified recycled polyethylene plastic in a standard asphalt binder, demonstrating a high level of undispersed agglomerated plastic particles. In contrast, on the right, You can see 3% green mantle wax in the same binder. The total absence of the light green particles is indicative of a completely homogeneous mixture. Green mantle waxes offer a revolutionary way to add waste plastics to asphalt while simultaneously enhancing performance. Compared to standard recycled plastics, green mantle waxes are easily mixed at lower temperatures with standard low-shear mixing. They remain stable and fully incorporated in the liquid asphalt binder for a minimum of 14 days with no additional mixing required. The ease of use and long-term stability of green mantle waxes translates to differentiated performance in asphalt compared to standard recycled plastics. Asphalt pavements must meet demanding engineering specifications. The drive for sustainability must always be responsibly balanced with asphalt performance standards and cost concerns. Green mantle waxes achieve this balance as they are specifically designed for compatibility with the liquid asphalt binder, providing improved rutting and crack resistance. This results in a more robust mixture with reduced fatigue damage, which translates into project cost savings through reduced pavement thickness and higher resource efficiency. The ability to pave at lower temperatures complements both the environmental benefits and further contributes to cost savings. Green mantle waxes are derived from 100% recycled plastics, so they effectively combine environmental benefits of sustainable content with performance and economic benefits. The following slides give a few examples of field usage and current projects with green mantle waxes. This first slide presents a paving program between Green Mantra and the City of Vancouver that's been ongoing since 2014. In this program, deemed Blue Box to Green Roads, the city uses green mantle waxes to enable lower paving temperatures, generating lower energy demands and a significant reduction of VOCs and fumes during paving. In the Middle East, one of our private partners uses green mantle waxes as part of a proprietary blend with ground tire rubber. Green mantle's waxes increase the workability of the mixture, allowing them to achieve a significantly higher loading level of ground tire rubber to create a higher performing asphalt that can be used in demanding heavy traffic areas such as industrial parks and construction sites. Another significant project specific to Pennsylvania occurred in March 2020 and should be officially announced in the coming weeks. This was a major project with a notable Pennsylvania-based private partner that validated the performance of our wax in a standard warm mix asphalt binder that's typical for the state. A test strip was placed in a heavy construction area, and the performance was carefully monitored for over a year against a controlled paving strip. The RPM asphalt with green mantle's wax has shown outstanding performance compared to the control, and the partners decided to move forward with a larger paving project in Q3 of this year. Finally, here's a summary of some of the most exciting projects we have ongoing at the moment. Our private project in Pennsylvania is one of the most exciting ones on the list, and we have active conversations ongoing with PennDOT to evaluate our material for wider use in roads in the state. We are really pleased to see the high level of engagement in Pennsylvania and look forward to expanding our presence in the state as we find more private and public partners willing to work with us on demonstration projects and private roads to further validate the performance of our recycled plastic waxes in asphalt. In summary, I want to highlight the significant environmental impact that exists within this new end market for waste plastics and films. Because green mantle's waxes are derived from 100% recycled plastics, they significantly enhance asphalt sustainability, creating environmental benefits by displacing a portion of the petroleum-based liquid binder and by diverting approximately 3 million waste plastic bags from landfill for every mile of road paved. It's an impact that we are looking forward to multiplying as we move forward with more projects in the state of Pennsylvania and across the rest of the United States. By collectively working together to validate these new markets, which in turn incentivize and drive collection of landfill-bound waste plastic streams, we can pave the way to a more sustainable future. Here's my contact information. Please don't hesitate to reach out to Kim or myself if you have any questions about the use of recycled plastics in asphalt or have ideas for collaborative projects in the state of Pennsylvania. Thanks again for your time today.